Now let's look at the fundamentals of linear regression. This is quite important. If you understand these fundamentals, you will understand the topic. And also in the interview, linear regression related questions can be asked. So please concentrate on this part. Okay, now I said the dependent and independent variables. So you should understand these terms very well. In this case, we can have different independent variables, one or more, but we will have one dependent variable. And we will try to predict, for example, this dependent variable like the price of the house. And this variable should be continuous data, not categorical data or not discrete. Let's remember the data types. So data can be divided into qualitative and quantitative data. And when I say qualitative, it's basically categorical data like spam email, secure email, Democratic Republican, remember the example. If they are nominal, if they are ordinal, so there should be some order like small, medium, large, x large, but still categorical data, still qualitative data. But when we talk about quantitative data should be counted, so numerical data. But also, this quantitative data is divided into two types, discrete and continuous. So when I say discrete data can take some certain values within a range. For example, think that dice, if you throw the dice, the result can be 1, 2, 3, 4, 5, or 6. There's no other option. It can take some certain values, not any value within a range, right? But when I talk about continuous data can take any value within a range. For example, it can be speed of car, it can be price of house, it can be weight of people, height of people. But another example for the discrete value can be the numbers of students in a class. It can be 20, 25, but some certain values. But if you look at the speed of drone, it can be continuous data because it can be 100 or 100.01, 100.0002. It can take any value. So we will deal with continuous data. And the second one is we will use some historical data to predict future. My question is, do you know what is overbooking? It is basically the airlines sells more tickets than seats. At the beginning, it can be ridiculous, but this is fact and it's quite logical because they know that some of the passengers will not come to the flight. But how? How can they know that? Of course, they have some historical data for passengers, for the flights, for the specific destination, and they use some statistical techniques to feature to predict. And I can estimate that, for example, 5% of the passengers will not come. In linear regression, we will use similar approach. We will use historical data to predict future. Of course, remember our problems will be more simple. And another point is, remember the equations. It will provide to understand the topic. When I say linear equation, y equals m times x plus b. Remember that y is our dependent variable, x is our independent variable, m is our slope, and b is our constant. If you look at the graph, you can understand that this angle is our slope, size is our x because it's our independent variable, price is our dependent variable and it's y, and b is our constant value. But remember, this is the equation of linear function. If you look at the linear regression models equation, you will see something like that. Very similar, but this will be our fundamental equation. Capitalized y, beta 0 plus beta 1, x, again capitalized x, plus epsilon. Quite similar because, again, y, here x, instead of m, we have beta 1, instead of b, we have beta 0. But we have also additional thing as epsilon, and it will represent error. But here, capitalized y is all observed values for dependent variable, all values. We will call this b, instead of constant, we will say y-intercept or bias. And this will be our coefficient instead of slope. And this x, capitalized X, is all observed values for independent variable, and the epsilon will be our error. So here we have something different, error. Now let's look at what is error. The basic definition of the error is the difference between the actual value and the predicted value. Think that actual value is 100 and I predict it as 90, so the difference is 10. So I can say that error value is 10 because the distance between the actual and predicted value is 10 in this example. It's quite simple. Let's look at our graph. Think that this blue line is our linear model. These orange points are the actual values. So basically, this blue line represents our model. In other words, for this specific independent variable, our model predicted this value, right? But here, as you see, the actual value is different. So we should understand the difference. So the distance between this actual value and this predicted part of the model will give the error. Of course, this is error for this specific point, but we should calculate the total error to understand the model's success. I will elaborate this part also, but for the moment, try to understand what is error. Okay, remember our equation for the model. So if we have one independent variable, we will call that simple linear regression model. But we can also have multiple independent variables, like in this example. The equation is again similar. This is our intercept point bias. These are coefficients for each independent variable sets. And again, we have error. So we will call it multiple linear regression model. Basically, we have two types.